Okay, ladies and gentlemen, boys and girls, I figured I would do a quick old school whiteboard style video. I wish I had a bigger whiteboard. Maybe we'll get one. We'll see how this goes. So I've done a video on boost control, like every form of it, and I will link that down below. If you are unfamiliar with how it works, you should probably watch through that, and it would explain a lot of probably what you have questions about. But this one's going to be a quick refresher for the Holly Terminator setup. That's primarily what everyone's asking about. I'm doing a lot of stuff with it. People have a bunch of questions about how does it work, what do I need to do. Terminator forums, the group on Facebook, not that great. A lot of people give out bad information, I think, on there. So when someone asks like, hey, someone the other day is like, do I need a dome sensor? And everyone's like, yes, and then you need to wire it into the map, and then you need to do this, and you need to use an input, and then you don't need to do any of that. You don't need to use boost control at all, quite frankly. So we need to go over, it depends on what you want to do and how you want to use it is how you should implement it. With all things in life, that you figure out what you want to do with it, you plan, and then you execute. It makes it easier for everybody. So anyway, see, am I at the right head height here? Oh, my head's so close. So we have two kinds of boost control we're going to talk about today for the Terminator. And what I always recommend people do is they go straight to open loop. And all that means is, for closed loop or open loop boost control, it's just like closed loop or open loop fuel control or anything in the computer. A lot of EFI systems use what's called closed loop. So what's happening is you have your target, and then you have your actual, and then you have your ECU, and then you have your change amount or percentage or closed loop, or when people talk about, oh, my closed loop was 40%, they're most likely referencing their fuel. So we'll say correction. So this is what's called closed loop. So you have your target, and then it looks at what your actual is, and then the ECU looks at both, and then your ECU makes a correction, and then it goes back and looks at the target again. So this can be summarized very simply. You say you want a 12O AFR. So you want a 12O air fuel. You're getting a 12.5 air fuel. The computer knows that you're slightly rich, so it takes away enough of a percentage. So the ECU goes, hey, I'm off target by 0.5. So it makes a correction of 0.5. And then it looks again, and if it's 12.0 and it matches, or if it goes back to 12.5 and it matches the actual, the ECU doesn't make a correction. So this is what closed loop is. So when people talk about open loop speed density, it means stock computer usually, in that they're turning off the O2 sensor loop. They're turning off the O2s and they're just running speed density map. So we're going to get back to this, and we're going to talk about how the boost control works. It works exactly the same way. Let's go over this. We'll get rid of my air fuel numbers, and what we'll type in here is, say you want 10 pounds of boost, and you're actually at 5 pounds of boost. So the ECU says you have an error of 5 pounds. So you're at a 5 pound deficit. So it goes +5, and then it hits a target. It's literally that simple, and it's doing this many thousands of times a second sometimes. Sometimes you actually have to adjust it because it can be so crazy, but that's all beside the point. So the easiest way, when I tell people to get boost control working for any aftermarket ECU that controls a 2-wire solenoid, you have, let's say, a MAC valve. So what you would do is you have a MAC, there's a 3-port, and then there's a 4-port. So the 3-port has the 2 wires, so it's a box, and it has 2 wires coming out, and then it has a port here, a port in the front, and a port in the side. That's the 3 ports. Now, classically, how this works is, you can see this on all the diagrams on the internets. You have your, say you have your turbo here, a little spinny boy, and then the boost is going into the intake, and then you're seeing, you know, 10 pounds here. And then here is, well here, man, I should have like got diagrams ahead of time. So here is wastegate with the top port and the bottom port on the wastegate. And then any pressure source is going to come through the 3 port. Usually what you do is you have your intake manifold and you're putting the pressure to the bottom, and say you're getting 6 psi. So what you do with a 3 port is you bring them over here and you take your intake and you go into the 3 port solenoid on the right. This is your vent. So this stays open so it can equalize pressure, it can let pressure out. And then the other side will go to the top of the wastegate. So then you have your 2 wires. Someone is blowing me up. What happens here is one of these wires is positive 12 volts. The other wire is grounded PWM through the ECU. That's how boost control works. So in layman's terms here, what we're going to say is, say you make 6 pounds and you tell the output of the computer to go 50%. So this solenoid is opening at 50% duty cycle. In a perfect world, what's going to happen is it's going to take 6 pounds from the intake and apply roughly what? 3 on top, half of 6 pounds. So you should get 9 because there's plus 3 going on to the top. So once you start to understand how this works, this is taking the pressure and allowing it to go to the top in a measured amount. So when I first get a car working with boost control in the dyno, to make sure everything is working, I disable closed loop because that can be a complicated process, teaching the computer how to adjust itself. Sometimes it requires fine-tuning. Most times it requires fine-tuning. So what you want to do is I set it up as totally open loop through an output, which I'll show you on the computer. I'll show you the difference. You have probably seen the other video where I go over the details of how to hook up the closed loop to make it work correctly. But there's a tuning facet to that I think I neglected to mention to you guys. I apologize. You can't just turn it on and it's great. There is tuning involved there, and it depends on all of these crazy things: size of your engine, size of your turbo, wastegate placement. Do you have a ton of wastegate? Do you not have a lot of wastegate? See, everything's going to struggle in its own way then, and then you have to adjust the settings to optimize that. It can even be something as simple as, do you have the air coming from the turbo or do you have the air coming from the intake? And then how large are your hoses connected to the boost controller? It sounds silly, but all of that stuff affects the speed and how well it can stabilize and all sorts of other things. So what I always do is, what you need to do is make sure this stuff works. You need to say, I no matter what, I have solid boost. That you need to have a solid, something to work off of. Otherwise you're just chasing your tail through all these settings, making it harder on yourself. So once you can make a reliable 6 pounds and you turn on an output and you can verify that through the data logs, say I have 25% duty cycle, say my boost goes to 9 pounds. Well, wow, we're in a good spot now. I'm saying to do something and I'm getting a result. And also, when I raise the boost, it's level also. So that's the whole game plan. So once you get all that working, then you can go in and enable the closed loop stuff. A lot of people get confused with how the 3 ports should work. It's really this simple. It's just this is normally shut. So when you say 10%, the valve pulses to let 10% of possible airflow through. And then all your other results depend on, like I said, base spring pressure, engine turbo size, back pressure, how effective everything is, blah, 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 blah. I don't know if this is more confusing or easier for people, but that's how it works. The boost controller always gets 12 volts, and one leg always goes to the ECU as an output. The ECU is outputting a signal to the boost controller as a ground. People are getting confused about input and output. An input is a input, like a temperature reading in, a frequency in, a TPS position in. A boost controller is the ECU is telling something to do something. It's not getting information, it's saying do this. So it's using an output. So that's it. That's basically the whole shebang. So that's how you get that working. I always recommend, even if you download one of my tunes, you should see in the output function, I have one called Dyno Boost. And that's just my sanity check. We get the car on, we turn off the boost controller. A lot of times I put a switch right here, taking the power, so I can turn the boost control completely off. So the boost controller can try to work, it won't work. It'll just run wastegate. Again, it's a good sanity check. If you have nice level boost and you don't have any mechanical issues, the electronics should work well after that, right? So once you have a stable platform, you can move up. Yeah, again, do the open loop first, and then you can enable a closed loop. There's also funny ways to hook up a boost controller, which there's a ton of diagrams on the internet. Maybe we'll show some when I jump to my desktop and show the software. But you can do funny stuff like, so this is always open and this is always closed. You can run, lines all over, and you can do top and bottom with a 3-port, or you can go to a 4-port. I always like to run 4 ports anymore because you have a greater window scalability of boost. So we can go over that also, and then how a 4-port gets hooked up is top and the bottom, and it does everything all at once. But I just wanted people to understand that quick. Hopefully that makes some sense. Maybe some people are more confused, but yeah. Anyway, so we'll take that and run with it and see what you guys think of it. Maybe we'll do a second video if it's super confusing. And then what I'll do is I'll show you on the computer what happens, how to do it, and go from there. And then I would like to put a car on the dyno sometime that struggles with boost control and show you guys how I tune it. I go into all those PID settings and the ramp rate, and I start fresh, and we'll see what it does, and then we will try to make it aggressively target as fast as possible without overshooting or oscillation or anything else. So we'll step over to the desktop now. Okay, so here we are at the software section. Like I said about open loop and closed loop boost control, so we will move on from there. And I did a whole video on how to make this closed loop work with the Terminator. There's some circumstantial stuff with the Terminator. For whatever reason, there's only dome control, so you can't do the easy stuff. So we're gonna bypass all that. And what you do is you go to outputs. So right here, I make a simple one called Dyno Boost. So this is just how you identify it and how you use it and what you look for in data logs. And it has to be PWM negative, so PWM ground. And then in configuration, what I do is I tell it to switch on. See, what happens here is if you mismanage your settings, the boost controller will be, say you set it at 50%, like I said, the boost controller will be vibrating at 50% all the time. You key the car on, it's gonna be running. What happens is it'll wear it out early, and it'll be annoying sometimes, and you won't know what the hell's going on. So what I do is I set input triggers to run the boost control. So I just say above 2 pounds, activate this whole output, and then below 1 pound, deactivate it. And then I have nothing else linked to it. A timer is all turned off. So what I have here is I have fixed pulse width. So there's RPM and fixed. And then I find with each solenoid has like a better working frequency range, but most like in between 10 and 30 hertz, in my opinion, a Mac. So a 4-port really likes about 18, and then I have it set up as duty cycle. And I do TPS versus map. And a nice thing about that is, I'll explain in a bit, what you can do with that. So you can modulate your boost depending on a lot of things. So once that's working, if you say here, like I have 45% here. So I have data logs here when I was on the dyno the other day. Right here, this is the wastegate hit. So you can see, we'll bring her over. Where is all of it? There we go. So here's all of it. Here is boost. 6.1 pounds pretty much the whole way. If you look up there, 6.2, 6.2, 6.2, 6.2, 6.2. So all of that is working fantastic. So then what I did, if we look here, I forgot to turn the switch on, which is why. So right here, we look at, I think I have one that says boost. Yeah, we can actually see right here. So if I take a look, there is, we have to edit the view quick, and then on boost, we have to throw dyno boost down. So you want to look at dyno boost is at 15%. I'm making 7 pounds now. 7 psi, 7 psi, 7 psi. So this is the stuff you want to make sure this works. Also, I forgot this. We have to go back to this. When you have closed loop boost control, it turns this guy on. P minus, pulse width modulated negative ground, boost plus solenoid. So that is because this is turned on. It's pretty much always stuck there. So what you have to do is take this guy off. If you're using closed loop and it's not working that great, you need to reassign dyno boost. I mean, that's why we name it that, so it's easy to understand what it is. You need to connect that to the pin, the output, then it all works. You just have to make sure you do that. I didn't want to skip over that and have people be like, I did that stuff and it doesn't work. Once you create that output, it creates a one to be assigned, and you have to assign it to the wire, the actual physical output wire. So if we go back into outputs and we look at the configuration on the pulse width side, this is the percentage. And then like I said, I did 15% duty. So this was 25% duty. As you will see, we will go into here when I roll in. We'll go look at the boost part of the thing. And right here, you can see dyno boost is not active. Dyno boost is not active. Dyno boost is not active. And I tell it to activate at 2 pounds. Bink. So at 2 pounds, like I told it to, it turns on 25%. So this stops it from, running all the time, like I had said. So here at 25%, now I have 9 pounds of boost. So again, this is one of those things. You want to make sure that this is working correctly, because that means all your mechanical things are working correctly, and it's going to make your life easier later on. So this whole process, like I showed on the board and like I'm showing here, it uses one output. It's using one, that's it. So hopefully Holley changes their settings. I think they will, that you can use more of these features, and just like the HP and the Dominator have a different setup where you can literally choose, I have a 3-port solenoid and I have totally open loop boost control, and then you can just literally set up those tables. It's the same, but it's not the same. So all you would do is adjust this table every time. And then the neat thing here is you can do, let me see, you can change this. Say you want to do, let's do TPS versus, here, let's change it to RPM, and let's change this to TPS. So say you want to do, you don't want to burn an input. You can't afford it. You're using it for something else. But you want to do, what's nice about the closed loop is you can say my car makes 6 pounds and I want 10 on the launch, and then I have this ramp for drag racing to ramp my boost in when I let off the brake. All of that's nice. And then you can also have the safety feature in, so that if it goes over boost, it can turn off the boost controller instead of doing a hard ignition cut. So you have those options too. All of that stuff is nice, but if you don't have all that functional, you can't do it. And then even here, I have the scramble button assigned to the bump. So after you have bumped in, when you're halfway down the track, you can hit bump again and it will add this 4 pounds on top of the target. So all of that's great, but if you can't use this input setup or you can't make it work correctly, you're not screwed. You can do fancy things with this. So like I just said, say you rescale this quick to 8,000. I keep missing the last 0. So now we will hit fill rows quick, and then this is TPS. So say my car on 45% here, if I show you, when I broke my timing chain, check this out. Look at that, broke timing chain, cam sync goes nuts. So right here, you can see, we'll go back to boost, 45% is making 18 pounds. So say this car makes 18 pounds, and that's what you like. And say you only want to make 10 on the launch instead of 18. Well, we found out through data logging that 25% made 9. And say you're on a trans brake, so you can go here and you can type in 25 at 3,000. So then here at 3,700, it switches over to 18. So now on the trans brake, wide open throttle, you should get, 9 or 10. And then after you leave and the RPM comes up, the duty cycle comes up. And so does your boost. Hopefully, if all goes well, right? And another really neat trick you can do here is, a lot of us already understand this, some of you might not. A turbo car like this, if it's making 800 horsepower and you have a street tire on it, and you foot brake it and you do a burnout and it has a 4L80E and it shifts up into third gear, it will absolutely annihilate tire, and you can pedal to like 40%, 30 sometimes, until you shut the throttle enough to slow down the incoming air to get the car back under control. All motor has a lot more pedal feel. You're controlling the air going in, but once one of these cars comes up on boost, like clears the hump, as I always say, some of these things, when they clear the hump, they're hard to stop. A lot of people crash these cars when they first get them built because they'll get back off half throttle and the damn thing makes the same amount of power. It's still totally screaming. So one thing you can do to get more feel or more control, if you street race or something, or you have this, it's a drift car, you can modulate the boost based off of TPS percentage. So say it's making 18 pounds. Let's go under 87% here. Let's turn it off at 0% throttle, and then we can take this whole block and we can fill it from 87%. Maybe you're not pinning it all the time. And what happens is you can say fill selected. So if you pedal the throttle down, it'll lower the boost controller amount. It'll effectively open the wastegate more, and it'll make the car, if you have a really punchy turbo car, this will make the engine feel bigger or smaller. You'll gain more control in your throttle, and you'll feel it. You'll tell the difference. And this stuff is built into the auto, the crazy closed loop features already, but you don't have it using stuff like this, but it doesn't mean you're at a deficit. You can also I think you can do boost time and other stuff. So you can set up a timer and then raise the boost as you accelerate over time, similar to these features, but you can do it all with the outputs. So hopefully this gets a lot of your brains working. You can do a lot of stuff with just these simple, this is why Holly says, like, we don't have something specifically, but we give you so much granular control over whatever you want that you can, if you can think about it, you can do it in most standalone systems. And this is just preaching to the choir here. Like, if you get this setup working like this, you're good. And you can even fade on the brake here. You can fade this too, probably to 67%, Fill all values. So yeah, so now you have a very linear, if you're wide open on the brake, it's going to run 25% and probably make 9 or 10 pounds. And then when you leave 45, make 18. Now this is just my car, but once you gather all your data, you understand how this works very easily. And then, like I said, using input triggers, the boost controller doesn't come on until you hit 2 pounds. So all your bases are covered for some really fancy stuff going on here. And it's literally a simple output. So I hope this helps a lot of people out. I hope they can, this demystifies a lot of it. It's not complicated, once you see how all this stuff works. So the whiteboard class and then the on-screen thing here, let me know what you guys think of this, if it helped out or if it made it much worse for you, and we can maybe make another episode or something. But I wanted to clear all this up. I had a lot of questions from friends, seen a lot of questions on the group. I'm like, yeah, I'll make that video. I'll make that. And I haven't done it. So I did it. So hopefully it helps. Thank you. Bye.